In this video, we'll discuss solids and surface area. Now, a polyhedron is a three-dimensional figure whose surface is made of polygons. They have faces, edges, and vertices. The faces are going to be all the polygons creating the outer surface. The edges are going to be where they come together, and the vertex are going to be the points where multiple faces come together. So if I look at this shape, I can recognize it's made up of faces. It's got edges where all the sides come together and vertices, those points where three of the faces are coming together, so that'd be a polyhedron. If I actually counted the number of faces, edges, and vertices, I would see there are 6 faces, 12 edges or line segments, and then 8 vertices or 8 points. Now if I look here, again, I have edges and faces and vertices, so I could say that this again is a polyhedron because it's made up of 4 triangles. So that tells me there's 4 faces, 6 edges, and 4 vertices. Now if I look here, I have a cylinder, but the thing is, a circle, which is making up 2 of the faces of the cylinder, are not considered polygons. So this is not a polyhedron. One of the ways we can find, if we know the number of faces or vertices or edges, we can find the others using Euler's formula, which says that the number of faces plus the number of vertices will equal the number of edges plus 2. So if I go back to those 2 shapes that I had, my 2 solids, if I think about what I know, I would take the faces plus vertices, 6 plus 8 is 14, and the number of edges plus 2, 12 plus 2 is 14. So that holds. If I look back at my pyramid that I had, made up of all triangles, I had 4 faces, 6 edges, and 4 vertices. Well, 4 faces plus 4 vertices equals 6 edges plus 2. That's 8 equals 8. So again, this holds true. Now there's certain types of solids that we should know about, one of them being prisms. And a prism is a polyhedron whose bases are congruent and parallel to one another. Now the base is going to be the polygon that forms the ends of the prism, whereas the lateral faces are all other faces. The base does not have to be the bottom of the shape. The base is just going to be the 2 parallel end pieces to the prism. So if I look at this shape, I have a lot of parallel sides, so technically I could consider any 2 parallel sides to be the base. This would be considered a rectangular prism because it's made up, if I think about this front being my base, that is a rectangle, and I think about the back, that is a rectangle as well. So those are my 2 bases. Those bases are rectangles. Now here, if I look at this prism, I say, well, what's the primary shape that's being stretched out? What are my 2 end pieces? And the end pieces are triangles, so I would call this a triangular prism. And here's a third example. If I look, what's the primary shape that's being stretched out? I see that I have a pentagon, and this pentagon stretched out to this pentagon at the bottom, so I'd call this a pentagonal prism. Now another shape we often deal with are cylinders, and cylinders are a solid shape that have congruent circles that are parallel to one another. So they can be vertical, horizontal, and you see this one on the right, it looks skew. It's shifted, it's slanted, and that's perfectly fine. That's just considered a non-right cylinder. We can have non-right shapes and solids, and that's perfectly okay. But they're still considered cylinders. And the final shapes we should recognize are pyramids and cones. Pyramids and cones will have a solid base, and then they're going to meet at an apex. Whereas a pyramid has a polygon for the base, a cone has a circle for the base. So if I look here, I say, here's my apex. What's my base that it's coming to? It's a triangle, so it's a triangular pyramid. If I look here, my base is this pentagon, and they're all coming up to this apex, so that's a pentagonal pyramid. And my third one here, I have a circle, and everything's coming down to this apex at the bottom. I would consider this a cone. Now, with all these shapes, we have a surface area. And the surface area is the area of the surface of a solid. So everything that makes up kind of like the skin of our shape. And one of the ways we can represent this is through a net. and this is taking and creating a 2D representation of the surface area of a 3D solid. Almost like you're peeling away the sides, kind of like if you think about peeling away an orange slice. You peel that side off and you can lay it down and see the three-dimensional solid as a 2D representation. So if I think back to the pentagonal prism, if I peel the two bases down and then fold off the sides, I end up with this net. You can see I have my two pentagons, and then I have my 5 lateral faces to the pentagon. So the reason we want to know this is because when we look for surface area, we can do one of two things. One, we can create the net and use the additivity principle to find the total area for a solid. Or two, we memorize and apply a set formulas for the solids. When we do this, we'd have to know specific things, such as that capital B is representing the area of the base. Capital LA, that's representing the lateral area, so the area of the faces. Capital P is representing the perimeter of the base. A little h is the height of the solid, so you got to figure out what are your two bases, and it's the perpendicular height between those two. And cursive L is the slant height, which is often represented on the lateral faces. So if I recognize those different pieces, I have 5 primary formulas for surface area. For any prism, I can do 2 times the area of the base plus the perimeter times the solid's height. For a cylinder, it's going to be 2 pi r squared plus 2 pi r times the height. So you're finding pretty much dealing with circumference components. The pyramid, we have the area of the base plus 1/2 the perimeter of the base times the slant height, so the slant height of the sides. The cone is going to be that pi r squared, that's the area of the base, plus pi r times the slant height, so r representing our radius. And a sphere is 4 pi r squared. Now let's look at 2 examples. First one, let's look at this rectangular prism that we have. If I wanted to, I could just use the formula, 2 times the area of the base plus the perimeter of the base times the height. I have to recognize, well, what am I calling the base? In this case, I'm going to call that front face the base. So it's that 4 by 3 rectangle. So if I think about the area of a base, that's 4 times 3. Area of a rectangle is length times width. So the perimeter then would be adding up the 4 sides. 3 plus 3 plus 4 plus 4. And that's going to give me 14 inches. Then I recognize my height, and you can see that it highlighted here, is that distance from the base, from one base to the other. In this case, that's 6 inches. So I put all those pieces together, 2 times the area of the base plus the perimeter times the height. And what you should recognize here too is by doing this, this is already in inches squared, and this becomes inches times inches, so that becomes square inches as well. I sum my two values and get 108 square inches. Now the other option would be to have created the net. So I peel away the sides and lay everything down and then label the parts that I have. So I recognize that I have 6 different rectangles in this shape, and I need to find the area of each rectangle. Well, I know that all the different segments have to be the same length, so I just need to label them correctly to put my areas into this problem. So here I recognize that since I was given that this was 6, all these vertical pieces here are 6. And since this horizontal piece here was 4, all of these are 4, which means this one has to be 4 because it was on the top. And then the shorter ones have to all be 3. So I'll find the area of each of these rectangles. Length times width, 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 length times width. Now I just add up all those areas, and I'll end up with the same solution of 108 square inches. And if you recognize, there's a lot of them that repeat. And another formula you'll see for a rectangular prism is that you can do 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height, which is pretty much what happens with these 6 shapes. Now let's say we look at a pyramid, and this pyramid has a square base, which is 3 inches wide, and a slant height of 6 inches. So again, I could use the formula I have, which is the area of the base plus 1/2 the perimeter of the base times the slant height. So if I label my base, I can say that the area would be length times width, since it's a 3 by 3 square, which is 9 square inches. The slant height and the perimeter would be adding the four sides together, so 3 plus 3 plus 3 plus 3 gives me the 12 inches. The slant height was given to me. That's representing the height or the altitude of each of the triangles on the sides. That's 6 inches. So I just put the parts into the formula. Area of the base plus 1/2 perimeter times slant height. 9 plus 36 gives me 45 square inches. The other idea would be to create the net. And if I lay it out, I just take my base and then I'm folding off the triangles for each of those. And I have all my parts labeled. I've got my 3 by 3 square on the inside, and then I've got 4 congruent triangles here where I know my height and I know my base. And you think about the area of a triangle is 1/2 base times height. So if I'm my area of my square, there's the 9 square inches. I can label all the other ones because they are identical triangles. And so I have 4 congruent triangles that are all 1/2 3 by 6. And if I think about what happens there, the first one of my 9 square inches in this case is the square, and then 9 times 4 is 36. It matches up with that perimeter times the slant height. So again, 45 square inches.